Okay, now I'm going to show you a little bit of a trick that you can use on certain types of optimization problems, okay? And this technique is where you take a function and you square the function. Okay, now why do we do that? Because what you'll see is that if f of x is positive on a certain interval, okay, so let's say f of x was positive on some interval like this, okay? So let's say between here and here, okay, it's positive on that interval. And in that interval, there's a maximum or a minimum somewhere at the point, let's say A, okay? What this rule is saying is that if I take this function and now I square it, I take all of the y values and I square them, I will still end up with a maximum, okay? If I square this term and this term and this term and this term and all of these terms, all of these values, I should say, what I'll end up with is I'll get something like this, okay? And I'll end up with some kind of function where the maximum, another function that will have a maximum at the same x value as the maximum on my original function. Okay, and if you think about it, it does make sense, because if you look at this y value is smaller than this y value, right? And so if I were to square both of these numbers, okay, this one would still be less than that number, the squared number would still be less than the squared number of the maximum. Okay, and that the same goes for if I have a minimum. Okay, if I had some kind of minimum and I squared this number, okay, I might get a number over up here. If I were to square this number is bigger than this number, right? This y value. So if I square it, it's probably going to be up here. Okay, so you might get something like this, where this would be the squared function and this would be the original function, and so the maxima or minima would stay would occur at the same x value. Okay, so if f of x is positive on an interval, on a particular interval, and inside that interval you have a maximum or minimum at x equals a, then the square of that function will also have a maximum or minimum at the function x equals a. Okay, so let's take a look at some examples here. All right, I have a list of functions here and they're squares. Let's take a look at each of these and see what happens. Okay, I have this function here. This is a cubic, all right? But we're only going to be looking at the positive side, and I'll show you why in a minute, why that is. Okay, if I square this, okay, I get this orange graph, okay? And so you can see here, this value right here is a little bit bigger than 2. If I were to square that number, I would get a little bit bigger than 4, okay, probably close to 5. And so you can see that there's a maximum occurring at the same x value, okay? If you look immediately to the left and right of this red function, okay, and I were to square each of these numbers, well, it makes sense that result would be less than the square of the maximum number, okay? So a maximum occurring on f of x would have the same x value as the maximum occurring on the square of f of x. All right, and this is always true for any f of x. Okay, now notice what's happening over here. So this is a negative number. This is a little bit bigger than negative 2. So if I square it, it would end up being positive 4 point something. Okay, and so that makes sense as well. That's why this rule will only work for positive functions. Okay, I'm going to skip this one. So let's look at another example here. Okay, if I click on this one, okay, if this is f of x times the square root of some function, and I were to square this, okay, notice that this is the interval that I'm interested in because this is the side that's positive. I have a maximum occurring, so I would expect to see a maximum occur somewhere around here. Okay, and I square that number, and you can see that we end up with the maximum occurring again at the same point. Okay, here's another example. This one is x squared times the square root of 9 minus x. If I were to square that, there you go. Okay, x is occurring at the same, maxima and minima are occurring at the same place. Here's an example of a minimum. Okay, this function, this one is hard to see. Okay, if I zoom out a little bit, okay, so you can see here that I have a minimum occurring. Okay, right at this point. Now notice that this is positive still. Okay, so this rule would still work. Okay, this side is all positive. Let's see what the square of that will look like. If I were to square this number, I would expect it to be pretty high. Okay, so oh, I'm sorry, I did the square root. Okay, so the square root would work as well. If I have this function and I were to square it, okay, then I would get this function because the square root part would disappear. Okay, and so you'd end up with this number here. Okay, so there you go. That's a rule that you can use when you are doing certain types of problems. And so this is useful if I have an f of x that is sort of messy, okay, where I have this kind of like a square root on one side that's hard to find the zeros of. Okay, if I were to derive this, it would be hard to find the zero of that expression. So I can square it and then find the zeros, and it makes my life a little bit easier.